brownout is a sudden and temporary reduction in voltage levels. This reduction causes lights to dim or appliances to malfunction. Brownouts typically last for a few seconds or minutes before voltage returns to normal. There are three main factors that typically cause brownouts. Firstly, high demand. When the demand for electricity exceeds the capacity of the power grid, the voltage can drop. This often happens during peak usage times, such as during periods of extreme heat or extreme cold. Secondly, power outages. When a power line goes down or other electrical equipment fails, it can interrupt the flow of electricity. This interruption causes brownouts in the affected areas. Thirdly, lightning storms. Lightning strikes can cause power surges or damage power lines, both of which can lead to brownouts. When a lightning bolt strikes a power line or transformer, it can cause overvoltage. The surge of electricity can overload the equipment, causing it to temporarily shut down or trip. This is a safety mechanism designed to prevent damage from excessive current or voltage. The lightning strike can also create an arc flash. Surge can create an arc of electricity which can short-circuit the line and cause a power outage. This is a dangerous phenomenon where electricity jumps across a gap, creating a bright flash and intense heat. Equipment damage can also occur. A surge can damage transformers, switches, and other equipment, which can lead to brownouts or complete power outages. This damage can require repairs and replacement of equipment. To protect against brownouts, firstly, use power strips with surge protection to protect sensitive electronics. These power strips are designed to absorb excess voltage and prevent it from reaching your devices. Secondly, consider installing a whole house surge protector on the electrical panel. This provides protection for all the electrical circuits in your home. Thirdly, consider backing up essential systems with a generator or uninterruptible power supply, also known as a UPS. This can provide power to critical devices during a brownout or power outage. The high demand in the power grid can lead to brownouts, especially during peak usage times. This is when everyone is using electricity at the same time, placing a strain on the system. When a power line goes down or equipment fails, the flow of electricity is interrupted, causing brownouts in the affected areas. This can be due to a variety of reasons, including weather, accidents, or equipment malfunctions. Overvoltage occurs when a lightning bolt strikes a power line or transformer, causing a surge of electricity that can overload the equipment. This can cause the equipment to temporarily shut down or trip, protecting it from damage. Arc flash is created by a surge of electricity from a lightning strike, which can short-circuit the line and cause a power outage. This is a dangerous phenomenon that can cause significant damage to equipment and pose a risk to personnel. Equipment damage can result from a lightning strike, as the surge can damage transformers, switches, and other equipment, leading to brownouts or power outages. This damage can be costly to repair and can disrupt electrical service. Power strips with surge protection protect sensitive electronics by absorbing excess voltage and preventing it from reaching the devices. This helps to prevent damage to electronics from power surges caused by lightning or other electrical events. A whole house surge protector installed on the electrical panel provides protection for all the electrical circuits in the home. This is a more comprehensive solution than using individual surge protectors for each device. Backing up essential systems with a generator or a UPS can provide power to critical devices during a brownout or power outage. This can ensure that important equipment, such as medical devices or security systems, continue to function during a power interruption. During a brownout, the voltage levels drop temporarily, which can cause lights to dim and appliances to malfunction. This is often a sign that the power grid is under stress and may be at risk of a complete power outage. Lightning strikes can cause significant damage to electrical equipment, including transformers, switches, and power lines. This damage can lead to brownouts and power outages, disrupting electrical service and causing inconvenience to customers. Surge protectors work by diverting excess voltage away from the connected devices, protecting them from damage. They typically use metal oxide varistors, also known as MOV, to absorb the excess voltage. Uninterruptible power supplies, also known as UPS, provide battery backup power to connected devices during a power outage. This allows the devices to continue functioning for a limited time, giving the user time to save their work and shut down the devices properly. Generators provide a source of backup power during a power outage. They typically use gasoline, propane, or natural gas as fuel. It is important to follow safety precautions when using a generator, such as ensuring proper ventilation. Electrical panels are the main distribution points for electricity in a home or building. They contain circuit breakers that protect the electrical circuits from overloads and short circuits. Circuit breakers are designed to trip or switch off when the current in a circuit exceeds the rated capacity of the breaker. This helps to prevent fires and other electrical hazards. Transformers are used to step up or step down voltage levels in an electrical system. They are essential components of the power grid and are used to transmit electricity over long distances. Switches are used to control the flow of electricity in a circuit. They can be used to turn lights and appliances on and off. Power lines are used to transmit electricity from power plants to homes and businesses. They are typically made of aluminum or copper and are supported by poles or towers. Electrical safety is important to consider. Never touch down power lines. They can be energized and pose a serious electrical shock hazard. Use caution when working near electrical equipment. Always disconnect the power before working on electrical circuits. Have a qualified electrician perform any electrical work that you are not comfortable doing yourself. Consider the age of your home's electrical system. Older electrical systems may not be able to handle the demands of modern appliances and electronics. Have your electrical system inspected by a qualified electrician to ensure that it is safe and up to code. Be aware of the signs of an overloaded electrical circuit, such as flickering lights, warm outlets, or a burning smell. If you notice any of these signs, reduce the number of appliances or devices plugged into the circuit. Do not overload extension cords or power strips. This can create a fire hazard. Use extension cords and power strips that are rated for the amount of power that you will be using. Keep electrical cords and appliances away from water. Water is a good conductor of electricity, and contact with water can create an electrical shock hazard. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical shock. Use outlet covers to protect children from inserting objects into electrical outlets. Regularly inspect electrical cords and appliances for damage. Replace any damaged cords or appliances immediately. If you are unsure about any aspect of electrical safety, consult a qualified electrician. They can provide guidance and advice on how to stay safe around electricity. The National Electrical Code, also known as the NEC, is a set of standards for electrical wiring and equipment in the United States. It is important to follow the NEC when installing or repairing electrical systems. It is also important to note that NEC Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating. These ampacity ratings help ensure conductors are not overloaded, preventing overheating and potential fire hazards. Similarly, NEC Section 250.122 provides requirements for equipment grounding conductors, ensuring a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers. NEC Article 408 covers switchboards and paddle boards, detailing construction requirements, overcurrent protection, and grounding. Following these requirements ensures safe and reliable distribution of electrical power. When dealing with voltages like 208 volts, 120 volts, 277 volts, or 480 volts, it is important to use appropriate safety precautions and personal protective equipment, also known as PPE. These voltages can be dangerous and can cause serious injury or death. Amperage, measured in amps, is the amount of electrical current flowing through a circuit. It is important to ensure that the amperage of a circuit does not exceed the rated capacity of the circuit breaker or wiring. Ohms, which are a unit of measure of electrical resistance, indicate how much a material opposes the flow of electrical current. A low resistance allows current to flow easily, while a high resistance restricts current flow. Considering all these factors can help prevent brownouts and electrical hazards.